Mr. Bergman, I have a very embarrassing confession to make.
Is that right?
Yes, my 5-year-old son
Yeah.
is much stronger than I am.
Really?
Yes.
Well, he's a stud. I hear he likes to hike.
He does, yeah.
10-mile hikes and craziness.
Yeah. So, I happened to record this on video.
Your wife
a couple days ago.
was catching it.
She did, yeah. She thought it was.
Got it on tape.
She thought it was pretty amusing. So
I think we should watch.
Let's
that.
take a look at that, and we'll tie that into electronegativity.
I think we probably should.
All right.
I have more muscles than you.
You have more muscles than me?
Yeah.
What makes you think that?
I think I'm more stronger.
Than me?
Yeah.
You think so?
Yeah.
Can you show me your muscles? Show me your muscles.
Where are they?
Like this. All right, tough guy. All right, so here we're at my house with my son here, and we're gonna have a little tug of war. Now, Zeke is gonna represent one atom that's participating in the bond, and I'm gonna represent another atom that's participating in the bond. And this rope right here represents the 2 electrons that are being shared in that bond. So we're gonna have a little tug of war here, and we're gonna see who wins. All right, Zeke, ready?
Yeah.
Set, go. Whoa! Whoa! You're winning! You're hogging the electrons! I can't keep them! Okay. So, what was going on there? You would expect me, the large, strapping man, to beat the small 5-year-old child in a tug of war. However, you saw that Zeke won. That could be because I'm puny and have absolutely no muscles whatsoever. Probably more likely, though, due to size. As we've learned before, atomic radius, ionization energy, it all comes down to the size of the atom. So, in terms of electronegativity, the smaller atoms always have a higher electronegativity. Reason being, those electrons can be closer to the nucleus, and they're going to be hogged even more. So, when you're thinking of atoms, you're thinking of electronegativity. Remember, the small atoms will have a higher electronegativity and are more likely to have the electrons more often in that covalent bond.
So electronegativity, very cool. All right, what is it? Specifically, it's the attraction of one atom for the electrons of another atom. So, Mr. Sims, when you were having that tug of war with your kid, the electrons of, say, calcium, the bigger substance, are drawn closer to the oxygen, because that's Zeke, and it steals the electrons. So the calcium loses electrons because he's weak, and the oxygen steals those 2 electrons. Notice that these 2 electrons move over, and then the subsequent picture is this -2 and +2.
So the takeaway from this is the smaller atoms have higher electronegativity.
Yes,
So my son, who's much smaller than I am, he won the tug of war because he wanted those electrons more than I did.
That's right. That's been like, yeah, that's right.
It's very embarrassing.
Yes.
Well, big now. Okay.
Okay, so the trend. So it all has to do with size.
Yes.
Because size still matters.
It does.
Okay, so as you go across the periodic table, they get higher.
Yes. Higher electronegativity, smaller.
And as you go down, they get lower.
Right.
Now, this is a little bit weird, though, because the top guy on the periodic table you would expect to be helium, and that is not correct.
No.
It's a little bit weird. So when you're looking at the periodic table, you ignore the noble gases.
Right. The noble gases don't count. And think about the definition of electronegativity. It's an unequal sharing. It's whichever one wants those electrons more within a chemical bond.
Right.
Our noble gases don't typically make chemical bonds.
So the guy who's the smallest and has the greatest pull is fluorine.
Right.
So fluorine has the highest ionization energy, and francium is the lowest. So I think, Mr. Sams, we should. Oh yeah, before we do that, it's kind of like this. So who's the top dog? The Arnold Schwarzenegger of the periodic table. It's fluorine. He's like muscle dude, and then a little tiny baby. Although the size thing.
That our pictures don't quite work in terms of size.
Yeah, but in terms of strength, the francium would be a weak
weakest
child.
Yep.
Yeah, okay. So I think we should look at a graph of this to kind of illustrate this.
Look, there's fluorine that wins.
And fluorine, he's got an electronegativity 4.0. That's the highest number it is. And you kind of see the trend, just like we talked about. So, and then we should do some examples. Hey, those same examples we've seen.
Ones again.
Hey, chromium or bromine?
All right, let's take a look. Chromium.
Hey, there's a chromium and there's a bromine. Hey, bromine is further over to the right.
It is.
He's closer to fluorine, and fluorine is the winner. So I'm gonna say bromine.
Bromine has the higher electronegativity. You're right.
And
Oxygen,
then
selenium.
oxygen and selenium.
Okay, oxygen is further up and also closer
Well,
to
he's
fluorine.
way close to fluorine.
So that one.
In fact, he's top. He's number 2 on the
Yep,
table. He's
that
like,
one
he
is-
may not be Arnold, but he's right next to him.
Yep. So highest one there. And platinum and sulfur.
There's
Platinum.
platinum, sulfur.
And sulfur is higher
Yeah.
and further to the right and closer to fluorine, so it has the higher electronegativity.
I believe we're done, Mr. Sams.
Atomic theory, folks.
Yeah. You really lost that thing to your son.
I know.
That's embarrassing.
Tell me about it.